Okay, let's take a look at shifting and reflection of graphs. Okay, these are some very common ones that we're going to use. The linear graph, which just has a slope of 1 and goes through the origin. The quadratic graph. Now, it's good to know the pattern that happens with the quadratic graph. It's going to make your life a lot easier if you can remember these patterns. Keep in mind that if I plug in, let's make a little table for it first. So if I did -2, -1, 0, 1, and 2. Okay, if I plugged in -2, -2 squared would give me +4. If I plugged in -1, -1 squared is +1, 0 squared is 0, 1 squared is 1, 2 squared is 4. So when you look at the pattern here, I've got 0, 0, up 1 over 1 on both sides, and up 4 over 2 on both sides. Okay, up 0, 0 is the start, up 1 over 1 on both sides, you get 1 and you get 4 for both the 2's. And then if I were to do one more, 3 and -3, okay, I would get 9 and 9. So up 9 over 3 and up 9 left right 3. So that's going to be our basic patterns. Okay, sorry. Start with 0, 0, up 1 over 1, up 4 over 2, up 9 over 3, because it's squares. You're squaring all those numbers. Okay, so same sort of thing. We need to have a basic pattern here. Okay, this one's a little bit easier for the square root. It does start at 0, 0, so when x is 0, y is 0. When x is 1, the square root of 1 is 1. Okay, when x is 4, the square root of 4 is 2. When x is 9, the square root of 9 is 3. Okay, notice that I skip around on the x value so that I have perfect squares. So when I graph these things, I'm going to start at 0, 0, and then I'll do 1, 1. And then I will go to when x is, we go up 2 over 4 and up 3 over 9. Okay, the great thing is that it is the opposite pattern over here. Here it's up 1 over 1, up 4 over 2, up 9 over 3. Here it's up 1 over 1, up 2 over 4, up 3 over 9. So they're just opposites of each other here. And this one you only do the one side. Absolute value should look like a V, has a slope of 1, so up 1 over 1 for each part. And it goes both directions. Okay, so we're going to use those a lot. We're going to use that pattern a lot. So keep that in mind as we go through these. So for instance here, okay, they want us to graph both the quadratic parent function and the quadratic plus 2. We've kind of already discussed this when we looked at making tables, but we're going to go ahead and look at it again. So start with the parent function. Okay, if you need to, go back to your reference up here, 0, 0, up 1 over 1, up 4 over 2, and up 9 over 3, and it's going to be the same thing on the other side. Okay, so that makes it very quick and easy to do our quadratic parent function when we're looking at these, and then you just draw your U. Okay, so what's going to happen when we have plus 2? Okay, so if I were to make this in a chart x, y, and I looked at those same values, okay, -2, -1, 0, 1, and 2. Well, -2 squared is still 4, but we're going to add to that, so we get 6. -1 squared is still 1, but when you add to it, you get 3. 0 squared plus 2 is 2. 1 squared plus 2 is 3. And 2 squared plus 2 is 4. Is 6, sorry. 2 squared is 4, 4 plus 2 is 6. So then when I go to graph this, when I go x is equal to 0, 2, okay, when x is -2, y is positive 6, when x is -1, y is positive 3, when x is positive 1, y is positive 3, and when x is 2, y is positive 6. Well, if you look at each one of those points, they both each one of them shifted up 2 units. Okay, up 2 units, up 2 units, up 2 units from there. So if you take each point and shift up 2 units, you're going to find your new graph. Because anytime we're adding outside of the function, okay, this means outside of the function because I've got x squared and then plus 2. So outside of the function is a vertical shift. So this thing will shift up 2 units. Okay. Okay, this is how we describe that transformation. Shifts up 2 units. When you're describing it, make sure you tell direction and amount. Up 2 units. Okay, so same thing happens here. Okay, we're going to do this again. So 0, 0, 1, 1, 4, 2, and 9, 3. And the same thing on the other side. There's my, oops, missed. Needs to be over 3. Okay, and then draw your U. It's a quadratic. It's got to have that U shape. So there's my parent function again. So then, if I were going to do this, okay, I'm not going to make a chart this time. This thing right here, it's minus 3. Okay, we just said that if it was plus 2, it went up 2. So minus 3 means it's going to go down 3 units. And you could check this with the table if you wanted to. Okay, but it's going to drop down 3 units. So what happens? Okay, this is the easiest way to do these. Take your origin. This is called the origin, is your starting point. Okay, so you're 0, 0. Go down 3 units. 1, 2, 3. Now you have 2 options from here. Memorize the pattern. Okay, so pattern goes up 1 over 1, up 4 over 2, up 9, 4, 5, 6, 7, 8, 9 over 3. Okay, and same thing other side. Up 1 over 1, up 4 over 2, up 9. I think I might be off on my 9. Let's see. And notice that I'm always going from the origin. Up 1 over 1, up 4 from the origin. 1, 2, 3, 4 over 2, and then up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. No, I made it. Just want to make sure I had them in the right spot. Okay, and then draw your new U shape. Now, I said there was 2 different ways you could go about doing this. Okay, one is the pattern. So up 1 over 1, up 4 over 2, up 9 over 3. Or you can go to each and every one of the points that you drew on the parent function and go down 3 units. Come here, you go 1, 2, 3, down 3 units. Come to this point. 1, 2, 3, down 3 units. 1, 2, 3, down 3 units. 1, 2, 3. Okay, so each point that I originally graphed has now all shifted down 3 units. So that's another way that you can look at that. Just up to you on which way you prefer. I suggest learning the pattern because it'll make graphing your parent function a lot easier, and it makes it a lot easier when we start doing the inverse functions. So I would suggest the pattern, but if you don't like the pattern, you can actually do the counting. So now let's make a little rule to go with those. Okay, vertical shifts. First of all, make note that it is outside of the function. Later on, we're going to look at stuff inside of the function. Okay, this is where we're going to have the function and then plus or minus some number. Okay, and then that's where your k comes in. F of x plus or minus some number. And we're actually going to leave it just as the plus, okay, because k can be positive or negative. So f of x plus some number over here. So let k be a positive number. When you add k to a function, it shifts the function up. So if this is plus k, it's up. And if you subtract k from the function, it shifts the function down. Okay, so if you get plus k here, you're going to go up. If you get minus k there, you're going to go down. That's all there is to it, just like here. This is my k value, so we went up 2 units. This is my k value, so we went down 2 units. Okay, that's really all there is to shifting vertically. So now let's take a look at, actually let's look at a few more that have a little more complicated. Okay, not that they're complicated, it's just good practice to practice graphing those parent functions. So for instance, this is my absolute value. Okay, so absolute value starts at the origin, has a slope of 1. So up 1 over 1, up 1 over 1. It says without plotting points, but if you need to actually graph up 1 over 1 so that your graph comes out pretty, there is nothing wrong with that. Okay, so I can do this, -1, da 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 da. Okay, I could easily do that so that I get a nice pretty graph and connect my dots. It's up to you on how you do that. You do need to be accurate with your graphs though. Okay, so then this right here, let's describe it first. Okay, so it's going to be a shift up 4 units. Okay, we know it's up because it's plus 4, so we're going to go up 4 units. So take this origin, go up 4 units. 1, 2, 3, 4. Okay, it's actually going to be called the vertex here. And then it still has a slope of 1, so up 1 over 1, up 1 over 1, up 1 over 1. Same thing, other side, up 1 over 1, slope of 1. Okay, notice that those things are parallel to each other. It's because they have the same slope. It's just the same graph moved upwards. Okay, that's all that happens. So same thing here. Here, do note that this is the square root of x minus 5. Since that square root stops on the x, okay, the 5 is not included in that. So this is outside. This is minus 5. So we do square root of x and then minus 5. That's a difference. Okay, so square root of x, if you need to, go back to the very top where we have the references. Okay, but I'm going to do my parent function. So when x is 0, y is 0. When x is 1, y is 1. When x is 4, y is 2. And when x is 9, y is 3. Here's your parent function. Okay, and now we need to take that parent function and go down 5. Okay, down 5 units. So let's go down 5 units. So we go 1, 2, 3, 4, 5. That's my new starting point. I'm going to do mine by pattern because I like it that way. Up 1 over 1, up 2 over 4, up 3 over 9. Again, if you don't like that manner, just come to each point and count down 5. Down 5, down 5, and that's going to be your graph there. Okay? So this one is my new graph. Alright, I would suggest that you hit the pause button, okay, give this one a try all on your own, and then come back and see if you got the same answer as I did. I'm going to continue on here. So starting with my parent function. My parent function here, this is a linear graph. It goes through 0, 0, and has a slope of 1. Okay, but it's not just positive, it's also negative. It goes all the way through. Okay, so all the way through both directions. Again, that's up there at the top if you need to reference it. Now, if I want to shift up, okay, because it's plus 3, so we're going to go up 3 units. So just start from that 0, 0, go up 3, 1, 2, 3. And my graph should be a slope of 1 in both directions. Should be parallel to the one that I just drew. Arrows both sides, so that would be my new graph right there. Okay, so that darker one, that's my new graph. So, that is going to be your vertical and your horizontal shifts. I think we're going to, or that's your vertical shifts, sorry. Okay, so now that we've looked at vertical shifts, we need to look at horizontal shifts. So let's see what happens. Now this right here means inside the function. The fact that it has a square means this thing is quadratic. Okay, so if you see something that just looks like this, where it was g of x is equal to x plus 2 squared, since it's x squared, that means it's quadratic, so my parent function is just the x squared. This is without anything being transformed. Okay, so let's go back to our parent function. Let's graph it first. I'm going to do it dotted this time so we can kind of see the two. Okay, so x starts at 0, 0, up 1 over 1, up 4, 1, 2, 3, 4 over 2, and up 9 over 3. Same thing both sides. And 9 and 3. Now again, I'm going to do this as a dotted line just so that it makes it easier to see the new graph. You don't have to do the dotted line. You can do different colors. You can do them both solid. Just a lot of people don't like the doing it solid because they say it makes it hard to read the graph or something like that. So if you want to use color or a dotted line for your parent function, there's nothing wrong with that. So there's my parent function. Okay, so now I'm going to take that function and I'm going to shift. I'm going to show it to you first. So if I were to choose x, y values, okay, we'll start with the same ones that I typically do. -2, -1, 0, 1, and 2. Okay, so if I did x is negative 2, negative 2 plus 2 is 0, 0 squared is 0. Negative 1 plus 2 is 1, 1 squared is 1. 0 plus 2 is 2, 2 squared is 4. 1 plus 2 is 3, 3 squared is 9. Okay, 2 plus 2 is 4, 4 squared is 16. Well, now here's a problem. I'm getting bigger, but I still haven't seen that change. Okay, I still haven't seen the change. Hold on, my screen froze yet again. That's what this thing does. Okay, so I need to pick more values, but I need to go to the left, because remember, I know it's a U, so I need to see that change in direction. So let's go more to the left. So let's choose negative 3. Negative 3 plus 2 is negative 1. Negative 1 squared is positive 1. Okay, so now we're looking good. Negative 4 plus 2 is negative 2. Negative 2 squared is 4. So now I'm starting to see those repeat numbers, which is what I want. So negative 5 plus 2 is negative 3. Negative 3 squared is positive 9. Okay, so now I should be good. Let's graph those. When x is negative 5, 3, 4, 5, y is negative 9. Oh, sorry. When x is negative 5, y is positive 9. When x is negative 4, y is positive 4. When x is negative 3, y is positive 1. When x is 2, y is 16. We can't do that. When x is 1, y is 9. When x is 0, y is 4. And when x is negative 1, y is positive 1. And when x is negative 2, y is 0. Okay, so if I draw this graph here, you should see now that what has happened is that we have actually shifted left 2 units. Left 2 units, which I know seems a little backwards, but the horizontal ones are. Okay? If it is a positive 2 inside, that actually means this thing is going to shift to the left 2 units instead of right 2 units. So if you took each point, it would go left 2 units, left 2 units, left 2 units, left 2 units, all the way around. You get left 2 units. So that's exactly what's happening. We get a left shift 2 units. So here, when it says x minus 3 squared, that is going to be right 3 units. Okay, because now it's always going to go the opposite of whatever that sign is. So it's going to go right 3 units. So going back to the parent function again, 0, 0, up 1 over 1, up 4 over 2, up 9 over 3. Same thing both sides. And I do keep saying it because I want it ingrained. Okay, because you do need to memorize these. You don't really necessarily have to memorize them. You can always just plug the values in and do it again. The numbers that I'm using are negative 3, negative 2, negative 1, 0, 1, and 2. So mentally you could always plug those in, but it's a lot easier just to memorize the pattern. But again, realistically, all that's happening there is you're just squaring each one of the x values. So if I go to negative 3, I square it, I get 9. If I go to negative 2 and square it, I get 4. Because it's a square function. That's what we're doing. So that's all that's really happening there. Now, when I go to move this, I'm going to go right 3 units. So start at the origin, go right 1, 2, 3, plot my first point. Okay, and then I'm going to do the pattern. So up 1 over 1, up 4. Notice again, always from the origin, 1, 2, 3, 4 over 2, and up 9 over 3 from my new vertex. Okay, up 1 over 1, same thing on the other side, 2, 4, and 3, 9. Okay, so when I draw my new graph, it looks identical to the first graph, only shifted to the right. Let me darken that up a little so you can see it a little better. Okay, so same thing as the first one, only shifted to the right 3 units. And that's all that's really happening here. So when you talk about a horizontal shift, okay, it's going to be inside of the function. So instead of x inside here, we have x minus h. Now it is good to notice that the minus h exists. That's why the thing goes the opposite direction, is because the formula is minus. So when you talk about this, it's a left 2 units, right 2 units. It's going to be opposite. So when you add h within a function, it shifts the function left. And when I subtract h within a function, it shifts the function right. Again, keyword there being within, okay, versus outside. So in general, the big picture looks like this. Well, I guess we'll get to that when we do the mix. I'll show you that when we get to the mix. Okay, so let's take a look at some of these. Let's do a couple more. So starting here, if I'm looking at absolute value, start with your parent function. I like these because it's just no points needed. You just do a slope of 1 this direction and a slope of 1 this direction. Okay, so there's my parent function. Now I need to do this. So this is inside. Okay, this is inside because they're inside the absolute value. If I wanted to move it up or down, I would put it outside of the absolute value. I'd say plus 4. That would move it up. This is inside, so this is going to be left 4 units. So here we go. Go left 4 units. 1, 2, 3, 4. Plot my starting point, and then it's a slope of 1 to the right, and a slope of 1 to the left. Okay, and that is my new graph. Let me darken it up a little bit here so you can see it a little better. Okay, that would be my new graph right here. Still got the V shape, just shifted over to the left 4 units. So same thing here. It's a minus, so we're actually going to go right 5. Again, this is how you describe the transformation. This would say right 5 units. That would be describing the transformation. So if you were asked to do that, and you will be, that's what they're talking about. Okay, just say, does it shift right? Does it shift left? How many? Up or down? All that kind of stuff. So, parent function first. 0, 0, 1, 1, 4, 2, and 9, 3. Draw my line. And then this is going to go right 5 units. So here we go. 1, 2, 3, 4, 5. Right 5 units. Up 1, over 1, up 2, over 4. And that's all I can fit on this graph, so that's fine. We're just going to stop there. Okay, if I can't fit any more points, then you don't worry about it. You just draw what you can fit on your graph. It's not a big deal. You don't have to go to 5 points if it doesn't all fit on one graph. Sometimes it won't. Okay, so that would be my new graph, that darker one on bottom there. So I take this time, okay, hit the pause button, see if you can do the next graph, see if you can get the same answer that I do. I'm going to go ahead and keep on going, starting with my parent function. 0, 0, 1, 1, 4, 2, 9, 3, other side. Okay, should match up. This thing is symmetrical about the x-axis, or the y-axis rather. Symmetrical, so same on both sides of the y-axis, if you wanted to know. Alright, so plus 7, that's going to be left 7 units. Left 7 units, so here we go. That's way over here. Here's my left 7 units, is where I started. Up 1, over 1. Up 4, over 2. And up 9 over 3. Okay, still have the U shape. If I get something that's not a U shape, I probably messed up somewhere. It should be a U shape. It's just shifted over to the left 7 units. That's a pretty good shift. Okay, so that would be my new graph there, the one on the left-hand side. Hopefully you got that one right. If not, you can always try it again. Okay, you can always pause, go back, try one more time. That is always a possibility. You can print out more blanks if you want to try, if you want to practice these same problems again. Okay, nothing wrong with that. So here, we're going to use both vertical and horizontal within the same graph. So our overall equation for both is x minus h plus k. Okay, this is our formula, f of x minus h plus k, where this is my horizontal shift, and it will be opposite of whatever the sign is, and this is my vertical shift. Okay, inside the function is horizontal, outside of the function is vertical. That is true with everything you do when we start talking about stretching and compressing or flipping and all that stuff. If it's inside the function, it's horizontal, outside is vertical. Okay, so start with your parent function like always, 0, 0, 1, 1, 2, 4. I hope I say this is enough that it just, you can't get it out of your head even if you wanted to. Okay, get that nice little graph there, and then, okay, describe the transformation. This will go down 2, left 3, and that's it so far. We'll talk about the rest of them in a little bit. So down 2, left 3. So here we go. Down 2 units, left 3 units. That's my new starting point. Okay, so then pattern, up 1 over 1, up 2 over 4, up 3 over 9, which would be right here. Okay, up 3 over 9, I believe, 1, 2, just make sure I got my points in the right spot, 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, notice I started here, not here. Okay, so draw my graph, missed my last little point there a little bit. Okay, draw that graph, should look something like such. Okay, which was down 2, left 3. If you're doing the counting method, okay, you would do the same thing. You would just go down 2 and left 3 for every point. Down 2 and left 3. Notice I end up on my points. Down 2, left 3. Okay, so you can still do the counting method there. Hit the pause button, try that on your own. Okay, come back, see if you got the same answer as I do. Here we go, starting with parent function. Up 1 over 1. Up 4 over 2, up 9 over 3. Those exist on both sides. Okay, I'm going to dot this one. Again, you don't have to dot it. The only reason why I am dotting is it just makes it a little bit easier to see which one is which. So here we are going to go up 1 and right 2. Up 1, right 2. That's my new starting point. Then do the pattern. Up 1 over 1, up 4 over 2, and then up 9 over 3. Graph those points. Connect my dots. Got my U. It is just up and over a little bit, and that's what that looks like. Okay, so that's transformations vertically and horizontally. So the last little piece we have to look at is just going to be the reflections. Okay, reflections. This is going to follow that same sort of rule. If it is outside, okay, if it's outside of a function, it is going to be vertical. If it's inside of the function, it will be horizontal. We are going to look at just the vertical. We're not even going to look at the horizontal. That negative, though. Notice it's a negative up front. I'm not talking about like minus some number or a minus inside. This is a negative out front, which means it's going to be a reflection. Let's go ahead and do our parent function first, and then we'll show you the reflection here. So up 1 over 1, up 4 over 2, up 4 over 2. Are you getting tired of hearing it yet? Hopefully it's stuck in your brain forever. Up 9 over 3. Okay, just squaring those numbers. So here is my parent function. Again, I'm going to kind of dot this just so that it doesn't get confused with the other piece. Da, da, da. There's my dots. There we go. So parent function graphed. Okay, it even says it right here. The graph of g of x and negative f of x is the graph of f of x reflected about the x-axis. Now that x-axis is actually important because you can reflect across the y-axis, which would be to go from here and reflect this direction. That's a reflecting about the y-axis. We're talking about reflecting from up here and flipping it down, what you're about to see. For instance, if I put in 0, negative 0 squared is still 0. So we're still at the same spot. Okay, but if I put in 1 here, 1 squared is 1, but that negative that's out front is not inside parentheses. If we wanted the negative to go inside, we would have said negative x squared. Okay, this, you would square the negative number. Here, that negative is going to be out front, and it's going to stay out front. So when you do negative 1 squared, it's negative 1. When you do negative 2 squared, sorry, I didn't mean to put a parenthesis there. When you do negative 2 squared, okay, that negative is going to be out front. Hold on, my screen froze again. This is a long section. Okay, so when you do the negative out front, it stays out front, so that would be negative 4. Okay, so if you do x is 3, that becomes negative 3 squared, which is negative 9. Now, if I start putting negative numbers in there, okay, so if I do negative 1 squared, negative 1 squared is positive 1, but I still have that negative out front. Okay, negative 2 squared, you have to, order of operations says you have to do the exponent first, so negative 2 squared is 4, and that negative stays out front. So hopefully we can kind of see what's happening here. That would give me a negative 9. So when I go to graph that, 0, 0, when x is positive 1, y is negative 1. When x is positive 2, y is negative 4. And when x is positive 3, y is negative 9. And it's going to be the same thing on the other side. Negative 1 is negative 1. Negative 2 is negative 4. I keep saying positive. And negative 3 is negative 9. So it is going to be a flip over the x-axis. Okay, so it is reflected about the x-axis. So that's what's happening here. So when you see that negative out front, so looking here, I've got a negative in front of my absolute value. That means it's going to reflect. So let's see. Let's start with my parent function. We'll draw it. Absolute value, slope of 1 in the right and negative 1 to the left should look like such. Helps if I stop turning it all sideways. Okay, so here, inside the function, which would mean a left shift of 4 units, and then negative out front means reflect across the x. Now if you want to say flip over the x, that's fine, reflect across the x-axis. Okay, if you don't want to say the axis, I'm fine with that too, but you do need to throw in that it is x, because we can flip across the y-axis. So reflect across the x-axis. So when I go to graph this, I will go left 4 units, 1, 2, 3, 4, left 4 units. Okay, and then instead of doing my slope up this direction, I have to flip it. So now I'm going to go slope down. It's still a slope of 1, so it's down 1, right 1, down 1, right 1, all that good stuff. It just has to go down this time. Same thing this side. It was supposed to go up 1, left 1, so now we're going to go down 1, left 1. Down 1, left 1, so slope this direction. So now it's just an upside down V, shifted to the left 4 units. Okay, so same thing here. If I do the square root of x, 0, 0, 1, 1, 2, 4, 3, 9. There's that graph. Okay, so negative means it's reflected, or we'll just say flip, because I know that's what most of you guys are going to write. Flip over x-axis. I'm okay with that. So then it still starts at 0, 0. And instead of going up 1, I'm going to go down 1 over 1. Instead of up 2, we go down 2 over 4. Down 3 over 9. So this is my new graph. Turn it so I can make it darker. Okay, so that bottom part is my new graph. Yes, this does look like a sideways quadratic, and it should, because x squared and the square root of x are actually inverses of each other, so it should look like a sideways parabola. Okay, so there's those two. Okay, so the very last part, putting it all together. Okay, so starting with this one, I've got that negative up front says flip. Okay, then positive 2 inside means left 2, and the negative 1 outside means down 1. Okay, you have to know all of these rules. Inside is left and right, outside is up and down, the negative out front flips. So, start with the parent function again. Let's graph it. Okay, and then I'm going to go ahead and move my origin first. So left 2, down 1 is where I'm going to start. And then instead of going up on both of them, I'm going to go down on both of them. Okay, so same thing here. Okay, this is the on your own. I would go ahead and hit the pause button, make sure that I can get the correct graph. Okay, I'm going to go ahead and do it. So starting with my parent function, 0, 0, 1, 1, 4, 2, and 9, 3, both sides. Sounding like a broken record right about this point. I think this is like the 10th time we've drawn a quadratic graph, but I am perfectly okay with it because I want you to remember it. Okay, so we are going to go flip. Okay, that's this part. And then inside we go right 3. And then outside here we go up 2. Flip over the x-axis, go right 3, and then go up 2. Okay, so right 3, 1, 2, 3, up 2, 1, 2. This is my new starting point, and then we're going to flip. So now, you can either take your paper and literally turn it around, and then graph. Up 1 over 1, up 4 over 2, up 9 over 3, or you can just count the other way. Down 1 over 1, down 4 over 2, and down 9 over 3. Okay, down 9 over 3. Same thing, other side. Okay, so just match them up over here. So it has been reflected. It has moved right 3. It has moved up 2. Okay? If you're doing the counting, okay, if you're trying to do right 3, up 2, since it's reflected, I'm going to have to go right from each point. I would have to go right 3. Let's see. Other than the origin, I would go right 3, up 2. Okay, but then for this point, which is now actually this point, I would have to go 1, 2, 3. That doesn't work. The counting won't work on this one. I'd have to go down 3, sorry. 1, 2, 3, 1, 2. You really don't want to do it that way, because that way it's going to get confusing. Because you're going to have to go down 3, right 2. Okay, you're going to have to flip them, since the whole thing is flipped, and that's not very fun. So I would highly suggest you just learn those patterns. Okay? Alright, and that is the end of transformations.